Here we look at one of the more complex basic functions, the reciprocal function. Reciprocal means flip a fraction over. So this reciprocal is if you flip x over, you get 1 over x. And that equation is the same as the equation y equals 1 over x. Okay? So before we get into the actual graph, let me give you some information here about fractions that you may have forgotten. So recall. If you have 1 over 1/2, that's the same thing as 1 divided by 1/2. And 1 divided by a half is 2, because a half fits into 1 exactly 2 times. 1 over a third is 3, because 1/3 goes into 1 3 times. 1 over a fourth is 4. 1 over 0 is undefined. There is no way to perform that calculation. Okay? So you need to understand how to divide 1 by some numbers, even these harder examples, in order to understand the graph that we're about to look at. So we have this equation, y equals 1 over x, and we want to graph it. And so for this function, we cannot plug in 0 for x, so we can't use 0. All right? So what types of numbers can we use? Well, we could use 1 for x, because I can take 1 divided by 1. I could use 2, 3, 4, but I could also use numbers. I can't use 0, but I can use numbers bigger than 0 and less than 1. So I could use numbers like a half, and a third, and a fourth, etc. Okay? So they're not 0, but they are getting close to 0. And usually, it's good advice, if you can't use a number, if you can't plug a number in, it's a good idea to plug in numbers that are really close to it so you can understand what happens as you get close to that. All right, so let's calculate our y values. Our y values here are calculated as 1 divided by our x values. So this will be 1 over 1/4, which we already said was 4 above. And similarly, 1 divided by a third is 3, 1 divided by a half is 2, 1 divided by 1 is 1, 1 divided by 2 is a half, 1 divided by 3 is a third, and 1 divided by 4 is a fourth. And so you can see why this is called the reciprocal function. The x and y values are reciprocals of each other all the way through. Okay, let's take these points and plot them and see if we can understand what's happening. Okay, I have my grid set up here. Let's start by plotting 1, 1, the ordered pair 1, 1. So that is right here. And then let's move to the right. If x is 2, y is 1/2. If x is 3, y is a little smaller, a third. If x is 4, y is smaller yet, a fourth. If x is 5, you can imagine it will be even smaller at a fifth. And if x is 6, you get 1/6. And if x is 1,000, which is way down the line, you get 1/1000th, which is so tiny. What we're seeing is, as we move to the right, our x values, if it'll let me graph it, are getting infinitely close to the x-axis, but it never touches the x-axis. Okay, so that's very interesting. Let's look at what happens if I look at the x values between 0 and 1, such as 1/2. If x is 1/2, which is right here, y is 2. And if x is 1/3, which is even smaller, y is 3. And if x is a fourth, y is 4. And so as you move this way, you can imagine that you're getting closer and closer and closer to the y-axis, and will never touch as well. Now, that's very interesting. You don't touch the x-axis, you don't touch the y-axis. You don't have an x-intercept, you don't have a y-intercept. Okay? But we're missing something. All we said was we can't use 0 for x. Well, we didn't use 0, but we also didn't use any negative x values. So what we're going to do now is look at more values to see what happens when your x values are negative. But we're going to choose similar x values. We'll choose like -1, -2, -3, -4. negative 1/2, negative 1/3, negative 1/4. And the y values will still be the reciprocals of these. 1 divided by negative 1/4 is negative 4. 1 divided by negative 1/3 is negative 3, and so on. 1 divided by negative 1 is negative 1. 1 divided by negative 2 is negative 1/2. And we can get the rest as well. Now if we plot these points, negative 1/4, which is really close to the y-axis, is negative 4. Then we have negative 1/3, which is a little further. We get negative 3 as our y value. Negative 1/2, which is a little further over, we get negative 2. Negative 1, we get negative 1. And you can see what's happening. In this case, we're still getting infinitely close to the y-axis, just in this direction, in the downward direction. And if I plug in negative 2 for my x, I get negative 1/2 as my y. Negative 3, I get negative 1/3. Negative 4, I get negative 1/4. If I kept going, negative 5, I'd get negative 1/5. And you're right, the graph gets closer and closer and closer to the x-axis as we move to the left. So this is a very unique graph. It doesn't touch the x or the y-axis, gets infinitely close to them, but never touches them. Gets infinitely close to the axes. Axes is plural for axis, so gets infinitely close to both axes, but never touches. And that is the graph of the basic reciprocal function f of x equals 1 over x.